Alright, how high can an hot air balloon go? First we start out by looking at where the forces are going to be equal, like the force of lift and gravity, and there's the hot air balloon right there. Lift is upward force, or buoyancy, not lift. And then gravity is the downwards force. And
which is also affected by the mass of the air balloon.
Yeah. So that's just our basic free body diagram.
And then gravity is caused by the attraction of two objects, being the balloon and the Earth, which are attracted to each other.
Newton's law.
Yeah.
Gravitational force.
And then the lift is caused by the hotter air, or buoyancy is caused by the hotter air inside the balloon, which decreases the density of the air in the balloon, so it's less than the density outside the balloon, causing it to rise, which is according to Archimedes' principle, stating that an object is less dense than its surroundings, then it'll be pushed upwards. Then the equation for gravity is just F equals mg, force equals mass times gravitational constant.
And though the gravitational constant would decrease very, very slightly as you go up into the atmosphere, it'd be pretty negligible just because we're not that high up yet.
And then Archimedes' principle, which is the buoyancy, is just volume times density times the gravitational constant. So, and then now we're going to look at how those change with altitude. So the ambient air density, it decreases as you get higher up in the altitudes, as in like the outside air density, and the outside air temperature also decreases. Like you said, the gravitational constant slightly decreases, but it's negligible. And then it's just the cooler and less dense air on the outside makes it more difficult to heat the balloon and get the air more dense than the outside.
I mean,
less dense. And then it can just go as high as the density inside the balloon equals the density outside the balloon.
And since volume displaced could be unlimited, we don't know how big the balloon is we're dealing with. We're just assuming that you have the biggest balloon you could possibly use. So really the limiting factors would be the air density. Because once you get to a point where the outside air density equals the inside air density, and you can't heat it to compensate for that, you're no longer going to be producing lift, and gravity is going to overcome, and you're going to start sinking.
Okay.
So we found for average balloons, we didn't actually get a number yet, but for average balloons, we found that that number is somewhere between 40 and 60,000 feet, depending on the volume. So light sport balloons, generally 40,000 feet, and some of the bigger, massive balloons, 60,000. So I think that's it.
Yeah.
All right.
And sources, we used ARC database. They had a article talking about how the atmosphere for performance, the balloon performance is affected by atmospheric conditions. So it's a good source.
Do you know what it's called?
It is called. It's on this piece. Yeah, it's at the top of one.
The performance theory for hot air balloons.
It's by K. Stefan.
Okay. Yeah, and that's what we use. So.
Yeah,
that's that.
cool. We're done.
All right, sounds good.